Hello everyone. Myself K. Arnakumari, working as Assistant Professor in the Department of Computer Science and Engineering, Sagi Ramakrishnan Raju Engineering College, Bhimavaram. In this lecture, we are going to discuss the second unit, Lecture 2, that is Relational Algebra. This lecture has been divided into two parts. The first part is going to deal with some operations of relational algebra, and the second part is also going to deal with the relational algebra but the remaining operations. And the objectives of this lecture are, we are going to discuss what relational algebra is, and also we are going to discuss the different relational algebra operations, which are termed as unary relational operations, relational algebra operations that are taken from set theory, and the binary relational operations, join and division. And we are also going to discuss some sample queries, which will be given as an exercise. Coming to relational algebra is a procedural query language. A procedural query language is a language in which the user is going to give the instructions for what is the data he wants, and also he is going to instruct how the data must be retrieved. So when a user is going to specify these two, that is what is the data and how it must be retrieved, then it is called as a procedural query language. It is a formal way to express a query in relational model. Here, a query consists of relational expressions which are describing the sequence of operators that can be applied to obtain the query result. It is going to consist of set of operations that can take one or more relations as input and produce a single relation as the output or result. These operations enable a user to specify the basic retrieval request or the basic queries. It is also called as a basic set of operations for the relational model. It is similar to algebra, mathematical algebra, where instead of numbers, we are going to have the relations in place of operands and also as output results. The relational algebra expression is a composition of relational algebra operations which is made possible because of the closure property. This relational algebra is going to act as a model for SQL by explaining the semantics, acting as basis for implementations, and also going to be as a fundamental to query optimization. The fundamental operations in relational algebra are select, project, union, intersection, set difference, Cartesian product, and rename. Along with this basic fundamental operations, we are having the other two, join and division. The select, project, and rename operations are called unary operations because they operate on one relation, that is a single relation. Union, intersection, set difference, Cartesian product are relational algebra operations that are taken from set theory. Join, division, along with the above said set theory operations like union, intersection, set difference, Cartesian product, all these operations perform the operations on pairs of relations, and so they are called as binary operations. For explaining these examples, we are going to consider two relations. One is the EMP table and the other one is the DEPT table. Here the EMP table is having the degree 9 and the cardinality 14. Means it is having 9 columns and 14 records. Coming to DEPT table, the degree of this DEPT table is 3, having 3 attributes and cardinality being 4 tuples. Now we will see one by one relational algebra operations. The first category is the unary operations, unary relational operations, where we are going to perform these operations on a single relation. The first one is the select, which is represented by the symbol sigma. This is the symbol we are going to use for this operation, sigma. This operation is used for selecting a subset of the tuples according to a given selection condition. Whatever the selection condition we have specified, that is being called as prepositional logic or predicate. Based on the satisfaction of that condition, the subset of the tuples from the relation will be given as output. It is used as an expression to choose tuples which meet the selection condition. That is what we said as predicate. The select operator selects tuples that satisfy the given predicate. The syntax is given in such a way that this is the operation or command select called sigma. P is the predicate or the prepositional logic, and R is the name of the relation on which this logic must be satisfied, and all the tuples which are satisfying this predicate or prepositional logic from this relation will be given as output. Now to explain this command, we are going to consider the EMP relation or EMP table, and we are going to write the command where we want to select the tuples from EMP table where the ename attribute having the value Smith. So this is the preposition logic or the predicate we have specified, where in our syntax this is being represented by the symbol P. And this is the command notation or symbol we are using, sigma. The predicate being ename, where ename is equal to Smith. In which relation? In EMP relation. So the output will be all the tuples where the ename is having the value Smith. So in our example, what we have considered, the instance, EMP instance, there in that instance we are having only one tuple with the employee number 7369 having the ename being Smith. See here, all the attributes or all the values of that particular tuple are given in the output. Now consider the second example. Here we are going to select all the tuples from the EMP relation where the salary attribute having the value greater than 2000. So in this salary attribute or column, whichever tuples are having the value greater than 2000, all those tuples will be given as output or given in the result relation. See here, the degree is 9, means all the attributes are being retrieved, and the tuples which are satisfying this condition, that is the sal greater than 2000, only those tuples will be given in the output. See here, we are having 6 such tuples in our EMP instance. Among the 14, 6 tuples are satisfying this condition, so those are shown in the output. Now, the second unary relational operation is the project, which can also be called as projection, and the symbol we are going to use is pi. Pi, this is the symbol we are using for this operation. This operation, that is a projection, is going to eliminate all the attributes of the input relation, but those mentioned in the projection list. Whatever are mentioned in the projection list, those will be contained in the output or result, and all the remaining will be eliminated. The projection method defines a relation that contains a vertical subset of relation. When compared with select, the select is going to give the output as horizontal subset of the relation, but coming to project, it is going to give the vertical subset of the relation. This helps to extract the values of specified attributes by eliminating the duplicate values. If there are any duplicate values present, those duplicate values will be eliminated in the output result. And then this operator helps us to keep specific columns from a relation and discarding the other columns. That is the main operation this operand is going to do. See, consider the example. Here in this example, we have considered the same EMP table, EMP relation, where we are trying to project the name of the columns EMP number and ename. These are the two attributes we want to display. All the other remaining 7 attributes are discarded from the output. See here, the output being EMP number and the ename, and all the 14 tuples. The instance, EMP instance is having the 14 tuples. All these 14 tuples are shown in the output, but with only degree being 2. That is the EMP number and ename. The next operation, unary operation we are having is the rename. This rename, the symbol used is the row. A row is the symbol used for this operation, and this is used for renaming the attributes of the relation. And not only the attributes, we can also rename the name of the relation also. See here, the syntax here explained is a row A by B means we want to replace the name of the attributes B with the name A. In what? In the relation R. In relation R, the name of the attributes are being B, but in the output we want them to be displayed as A. The attribute names to be as A. See here in the examples, we are giving three different scenarios. The first one being the renaming the name of the relation. We are trying to rename the name of the relation. The actual name of the relation being R, but using this command row, we want to rename the relation as S. Remember, this renaming is done only for the output results. We are not going to change the actual name in the database, name of the relation in the database. This is only for the output relations or the output results. Then we are having the next example, which is going to show the renaming the attributes. See here row B1, B2, so on, Bn. Means we are trying to rename the attribute names which are A1, A2, so on, An with B1, B2, so on, Bn of relation R. And then we are having the third example where we are trying to rename both the relation name and also the attribute names. See here row, we are trying to rename the relation R with relation S being S and the attributes from A1 to An to B1 to Bn. We are trying to rename the attribute names also which are from A1 to A1, An. We are trying to rename them with B1 to Bn. Means we are trying to rename all the attributes in that relation. And the next set of operations we are having are the operations which are retrieved from the set theory. The first among them is the union. The symbol used is the U symbol for that. And it is going to include all tuples that are in tables A and or in B. Means all the tuples which are present in table A or all the tuples which are present in table B. And it is also going to eliminate the duplicate tuples. So a union set B would be expressed as A union B. This is how we are going to express this operation. For this operation to be performed, we have to satisfy three conditions. The three conditions are, the first one being both the relations must be the same number of attributes. Both the relations must have the same number of attributes. And the second condition being all the attributes domains must be compatible in the two relations. Both the relations attribute domains must be compatible. Domains means what? If column 1 in table R is integer type, the column 1 in table B table S also must be integer. And the duplicate tuples should be automatically removed. Whenever there are duplicate tuples which are existing when this operation is being executed, those duplicate tuples must be automatically removed. When these three conditions are satisfied, then we are saying that these two relations are union compatible. Only when they are union compatible, we can perform this operation. Consider the example here. Here in this example, we have taken two tables, table A and table B with two columns. Means the degree being 2 and also the cardinality being 2. Both are having two tuples with values 1 and 1 in the first tuple and 1 and 2 in the second tuple of table A and 1 and 3 in the second tuple of table B. The output which is given as A union B will be having the degree will be 2, that is column 1 and column 2, and coming to the output, all the tuples in A and all the tuples in B will be present in the output. But only thing is the duplicate tuples will be eliminated. Only one tuple will be there. The other which are repeating will be eliminated automatically. See here, the tuple 1 in table A and tuple 1 in table B are repeating. Means they are duplicate. So only one such tuple is present in the output and the other one is eliminated in the output. The second tuple being the second tuple in table A and the third tuple being the second tuple in table B. Then we are having the second set theory operation, set difference, which is represented by the symbol minus. This is a relation, the output of this operation will be a relation which includes all the tuples that are in A but not in B. All the tuples which are in A but not in B will be present in this, in the output of this operation. The attribute name of A has to match with the attribute name in B. Means the two operand relations A and B should be either compatible or union compatible. Here compatible means type compatible. Both the columns must be type compatible. Union compatible means the three conditions must be satisfied. So for this operation to be performed, it is sufficient that either the operands, the two operands of the relations might be compatible or they can be union compatible. And it should be defined relation consisting of the tuples that are in relation A but not in B. Consider the same example, the two tables, table A and table B. The output of this operation A minus B, we said that all the tuples which are in A will be present but not in B. See here, the tuple 1 in table A and the tuple 1 in table B is present in both. Means it is repeated. Means it is present in table B also. But the output must have only the tuples that are present in A. So only one tuple is there with the values 1 and 2 in column 1 and column 2 respectively, which is present only in table A but not in table B. So that is shown in the output here. So table A minus B, the output of A minus B operation is going to have only one tuple, that is the second tuple from table A. The next operation we are having is the intersection, which is represented by an inverted U. This is the symbol we are going to use for this operation. And we know in set theory, here which is shown in this diagram, only the tuples which are present in both A and B will be given in the output. See here, only the tuples which are present in this marked area with red lines, only those tuples will be in the output. See here, the other thing is they must be union compatible. So for performing this operation, the two relations must be union compatible. Only then we can perform this operation like union. Union compatible means three conditions must be satisfied. The first one being all the same number of relations, the same number of attributes must be present in relation A and relation B, same number. Means the degree must be the same for both the relations and the domains must be the same. The domain of the attributes of relation A must be compatible with the domain types of the attributes in relation B, and if there are any duplicate values, those must be automatically eliminated. These are the three conditions that must be satisfied for being or to say that the relations are union compatible. So for performing this intersection operation, both the relations which are participating in this must be union compatible. So consider the example, the same two relations we have taken, table A and table B. And here this is the output of the operation A intersection B, where it is having the tuples which are common in both the relations. So here in this example, in table A and table B, we are having one tuple, that is the first tuple in table A and first tuple in table B, which are having the same values. Means which are common. So only that one will be given as output here. So column 1 and column 2 having value 1 and 1, which is the first tuple in table A and the second tuple in table B. As we said that no duplicates are allowed, so only one tuple is shown here and the other one is eliminated automatically. The next operation we are having is the Cartesian product, which is represented by X, or we can say it as into symbol. And this operation is also called as cross product, or in some cases it is also called as cross join. And this Cartesian product is being applied on two relations. that is on two sets of tuples, where every tuple in one is taken one by one from the left side relation and will be paired it up with all the tuples in the right side relation. Means what? Each and every tuple in the first relation, that is the left side relation of this symbol, of this Cartesian product symbol, the left side relation, each and every tuple will be paired with all the tuples in the right hand side relation of this operation or this symbol. The two relations on which we are performing the operations do not have the same type of tuples, which means they need not be union compatible or type compatibility. This is not necessary. For this operation to be performed, we need not say or we need not require both the relations to be either union compatible or compatible, means type compatible. The syntax is given as follows: A into B, where A and B, here sorry it is B not S, A and B are the relations and the symbol X is used to denote the cross product operator. And here consider the, so in this example we are considering two relations, one being the student and the other being the detail. Here the student is having three attributes, one being the student number, first name and last name. The detail having two attributes, roll number and age. See here, this is the student instance and this is the detail instance. Instance is nothing but at that particular period of time, what is the state or what are the values that particular relation is going to have. That is called as an instance. So here in this student instance, we are having at that particular time, we are having two tuples, and at the same time detail is also having two tuples. So now we are going to perform the cross product or Cartesian product operation on these two relations. Student, Cartesian product, detail. So this is the left hand side relation and this is the right hand side relation. What this operation is going to do? This operation is going to take each and every tuple from the left hand side relation, that is the student relation, and it is going to pair with all the tuples in the right hand side relation, that is the detail. See here the first tuple in this output, student cross detail. See the first tuple in the student which is paired with the first tuple in detail. The second tuple being the first tuple in the student paired with the second tuple in the detail. The third tuple in this output relation is going to be the second tuple in student paired with the first tuple in detail. And the fourth tuple being the second tuple in student relation paired with the second tuple in detail. So here this is the output of the Cartesian product or cross product. What you have observed here, see here, what is the degree of this particular output relation? The degree will be the sum of the degree of both the relations which are participating in this operation. What is the degree of student? It is 3. The degree of detail? It is 2. So it is the summation of the degrees of these two relations. So 3 plus 2 it is 5. See here the output student cross product detail is having 5 attributes in its output. Means the degree of this is 5, which is the summation of degrees of student and detail. And coming to the tuples, this will be the multiplication of how many tuples we are having in student relation into the how many tuples we are having in the detail relation. Here in this example, we are having 2 tuples in student and 2 tuples in detail. Means 2 into 2, 4. So the cardinality or the number of tuples which are present in the output of this particular operation is 4 here. Means if we are having m tuples in the left hand side relation, that is student, and n tuples in the right hand side relation, that is detail, the cardinality of the output of this operation will be m cross n. This is the cardinality of that particular output relation of this particular operation, that is the Cartesian product. and the remaining operations will be discussed in our part 2, that is the lecture 2 of relational algebra. Thank you for now.